Assalamualaikum and good day to all students. This video is for Program Kecemerlangan Akademik KMNS, Score Program Semester 2, Session 2021-2022. In this video, I will be showing you how to solve questions from PSPM Chemistry 2 SK025, question number 2. Question 2a. Ethanol CH3CH2OH is produced from fermentation of sugarcane and widely used as an alternative fuel to replace petrol. A 1 gram sample of ethanol was burned in a bomb calorimeter, which has total heat capacity of 11 kJ per degree Celsius. The temperature of the calorimeter and its content increased from 25 degrees Celsius to 27.7 degrees Celsius. Question 1. Write a balanced chemical equation for the reaction that takes place in the bomb calorimeter. In order to answer this, students need to know the phases as well as the balanced stoichiometric coefficient. So the answer is CH3CH2OH liquid plus 3 O2 gas producing 2 CO2 gas plus 3 H2O liquid. And this is the mark for this question. Question A2. Calculate the enthalpy of combustion of ethanol per mole. To start this question, students need to calculate the number of mole of ethanol first. 1 gram divided by 46 gram per mole, the answer is ethanol has 0.02174 mole. Next, we calculate the heat released by the reaction, either Q or negative Q, because enthalpy of combustion is defined as the heat released. So Q equals to C delta T of the heat capacity calorimeter multiplied by the temperature difference. 11 kJ per degree Celsius multiply 2.7 degrees Celsius. 2.7 is from 27.7 minus 25 degrees Celsius. So the answer for Q is 29.7 kJ. These are the marks for this part of the question. Next, we do stoichiometric coefficient. 0.02173 mole of ethanol releases 29.7 kJ. It means if you have 1 mole of ethanol, it will release 1366.15 kJ. So this amount of heat release for 1 mole ethanol, it means that the delta H combustion is negative 1366.15 kJ per mole. So these are the marks for this question. Moving on to question 2b. Born-Haber cycle for the formation of calcium sulfide is given in figure 2, and the cycle is not drawn to scale. Question number 1. Name the enthalpy changes for delta H7 and delta H8. So delta H7 is found here, which is the lattice energy of calcium sulfide or CAS. Delta H8 is found here, which is the enthalpy of formation for calcium sulfide or CAS. These are the marks for this question. Question number 2. Identify the species X formed from delta H5. So this is delta H5 and this is X. As you can see, X is coming from sulfur gas, and after X, it becomes sulfur 2 minus gas. So X is going to be S minus gas, which is the first electron affinity of sulfur gas. Next question. This is the mark. Use the data in figure 2 to calculate the value of delta H6. So delta H6 is here. So in order to calculate delta H6, we need to use Hess's law. So from Hess's law, the delta H formation, which is down here, the delta H8, is equals to delta H1 plus 2 plus 3 plus 4 plus 5 plus 6 and plus 7. So filling in all the delta H with the values given, delta H6, rearranging this equation, we get positive 539 kilojoule per mole. And these are the marks for this question. Question number 4. Will the lattice energy for CaO be larger or smaller than CaS? Explain briefly. So in this type of question, students need to identify the difference that you see in CaO compared to the CaS. In this case, the anion are from different atoms. Oxide ion, O2 minus, versus sulfide ion, sulfur 2 minus. So this factor is the size of ionic radii. So CaO will have the larger lattice energy than CaS. Reason why? Because the oxide O2 minus ion has smaller ionic radii than sulfide S2 minus ion. So these are the marks for this question. Moving on to question 2C. Given the following thermochemical equations, enthalpy formation of CO2, enthalpy formation of SO2, and enthalpy formation of CS2. Determine the enthalpy change for the following reaction. These equations are given CS2 liquid plus 3O2 gas producing CO2 gas plus 2SO2 gas. Students are able to use two different methods. Method number 1, by using formula. Enthalpy of any reaction is equals to the summation of enthalpy formation for all the products minus summation of enthalpy formation for all the reactants. In this case, the products are CO2 gas and 2 mole of SO2 gas, and the reactants are CS2 liquid and 3 mole of oxygen gas. So, enthalpy formation of CO2 is negative 393.5, so we insert here. Enthalpy formation of SO2 is negative 296.8, we insert here. And we multiply by 2 because there are 2 moles of SO2 in the equation. Minus the reactants, enthalpy formation of CS2 is negative 87.9, we insert here. And enthalpy formation of oxygen is not given. However, because oxygen is at its most stable state, O2 gas, its enthalpy formation is 0 kilojoule per mole. So 3 mole multiplies 0. So you will get your answer to become negative 899.2 kilojoule. So in this case, there is no mole minus 1. And these are the marks for this question. The alternative method to this question, students can also use algebraic method. So to use algebraic method, students need to rearrange all the enthalpy formations given so that you can get the targeted equation here. So by arranging all this equation, students will also be able to calculate the summation of all the enthalpy here and will get the exact same answer as using the calculation formula earlier. Negative 899.2 kilojoule. And these are the marks for this question.